everyone, my name is Pierre. I'm the CEO and co-founder of Pixeltable. I'm using a notebook to demo, so I'm a bit old school. I used to run a notebook company called Notable, so that's why. So Pixeltable is an AI data infrastructure for declarative incremental approach for multimodal workloads. With building workloads or application with multimodal data, video, audio, document. Nobody is ingesting video, document, audio. 1, 2, 3. Everyone else is using structured data. Okay, that's the demo is for those 5 people here. And everyone, if you don't use multimodal data, it's a great way to get started. So when you use multimodal data, what's difficult with it is you think about video, audio, document. You have with LLM and other applications like computer vision and machine learning. You have to chunk them. You have to think about caching. You have to think about versioning, lineage. How do you materialize the data? Because it's a lot of data. Most of it sits in your blob storage against your structured data sitting in an RDBMS system. So building complex pipeline to train models for computer vision or using with LLM more than just a simple chatbot is actually quite complex and requires a lot of solution. So in Pixeltable, it's pretty easy. You can install it as an SDK. You're gonna create a table like if you're in a database system. When you create a table here, we have all the data types that you can imagine: document, video, audio, string, JSON, array, and you'll see what neat it is. So here I'm creating a table with a string type and video type, which means now I have a table in a database with 2 columns, one being a string type and one video type, which means I can insert actually a video. So I'm gonna insert a video sitting in GitHub, but that video could have been in S3, could have been in NX or data store, as well alongside, let's say, metadata here called location Bangkok. And here I have a video sitting in my reference in my database system with the related metadata. So I've shown you already, you have a data store with structured data and unstructured data living side by side. There's already a lot of benefits by doing that. But in Pixeltable, there's something even neater, which is actually unifying orchestration and storage. Normally, if you think about working with video, audio, document, JSON array, and orchestrating transformation or inference on it, you're gonna bring all of that in memory, run a pipeline, look at it, iterate over it, and then that's pretty much what you're gonna do. You don't have visibility into the intermediate states, the caching, the lineage of it. Pixeltable gives you that. Here we're gonna create a view. Why do you want to create a view on video usually? Because you want to work on the frames. Because LLM understand images, not videos. Computer vision models understand frames, not videos. That's what you do inferences on. So here we're gonna actually chunk the video into frames. We are here creating an orchestration in the database itself. We are saying, let's take all the videos, chunk them into frame with this frame iterator, and like that we make them available at runtime. I'm gonna run a query. I'm gonna say, hey, let's look at this frame view, select all those columns, and look at that, I have the frame of the video. So we have built a pipeline and a storage system in 5 code cells. What do you want to do with it? That's cool. You tell me, Pierre, now we have a video, we created some frames. What can I do with it? In reality, I might use a computer vision model, an LLM. So let's use a computer vision model. Let's use the YOLOX here, which is just a UDF, a user-defined function, and let's actually run inferences on those frames. Why do you do that? Because you want to create and augment your data with metadata so you can then train your model or serve your application. And those bounding boxes, oh, it's a JSON, so that's cool, and you're gonna tell me, can I actually query or do something with the JSON? Yes, you can. Now in your database system, you have your frame, your JSON, and now you can say, okay, maybe let's look at that JSON and build bounding boxes. So I'm actually gonna create a computed column. A computed column in Pixeltable is basically like a persistent orchestration in an ETL. You are here creating a DAG. You are telling the database system, here's my new computed column called detection, and the DAG is basically take this UDF called YOLOX. The input is another column in the table, and this is just a parameter of that UDF. By doing that, I have actually declared my DAG. So you can see the frame view here that contains all the metadata of the frame, as well as the base video, now contains the orchestration of actually doing local inferences on those frames. In that one table, I have lineage to the raw data video. I have all the metadata regarding me chunking my video into frames, and I have a local inference. You have everything you need to do any type of multimodal workload in a database system that gives you versioning, lineage, parallelization, async execution, out-of-memory evaluation. And it's just one Python SDK. So what else can you do that's neat? Let's say you look at the detection, which is a bunch of bounding boxes. What people do a lot of times, let's say, okay, let's actually digest that with a UDF to build a bunch of boxes. So I'm going to do that. I wrote a UDF. You can write it yourself. Draw bounding boxes. I'm just running query, so I'm just like doing like an in-memory evaluation here, and that query show me the bounding boxes. Let's do another quick transformation for fun. Let's make a video out of it. Here I just run a query to actually take a segment of more of my frames. So now we have shown the video into frames. What am I doing here? I'm actually gonna recreate a video clip, but augmented with the inferences that we did, and then drawing the box on it. Now let's look at bring LLM, because everyone talks about LLM lately. LLM, what is it? It's just a function call. So I'm just gonna do another function call with a computed column, again using the frame, and I'm gonna say, okay, what vehicle types are visible in these images? You're gonna see the LLM is just now with a computed column in my table. So I'm gonna have my frame with the output of that function call. So what did I just build? Now if I run a query on my view, you can see I'm gonna query the location, which is the input, the video. This video is from the original table. My vision column is my LLM call. My bounding boxes is my local inference to my computer vision model. And this is me now additionally running in memory another bounding boxes. You can see in one table I have structured data, unstructured data, LLM inference, JSON, and in-memory UDF that I wrote myself. And I can change that to say oranges, not oranges, orange. Oranges will be weird. And now it's orange. And I'm gonna say that. That's just a UDF I wrote, red. And you can see when I run this query, I only rematerialize this, because all the rest were persistent computed column. This is pretty much it. I showed you how you get with one Python SDK that's open source that you can find on GitHub, a native multimodal data type database, an orchestration system that's declarative, and a comprehensive query language. And I didn't show you what else you can do, which is adding embedding index and doing drag and all this stuff. Thank you.
Next, yes.
I have 10 seconds for questions.
No.
No questions?
Just go. This is 10 seconds. We're not doing it in 10 seconds.